Bismillahirrahmanirrahim. Assalamu alaikum students. With the new video, in previous video we discussed pH and pOH scale. Now in this video we will discuss the pH regulation of the stomachs, neutralization reactions and types of solutions. First topic is pH regulation of the stomach. As you know students that our stomachs produce gastric juice, and this gastric juice contains small amount of hydrochloric acid, mean HCl. Due to presence of this HCl, the normally the pH of the stomach is very low, mean up to 1 to 2. Hydrochloric is produced by the gastric gland present in the wall of stomachs, and due to the presence of hydrochloric acid in stomach HCl, the pH of the stomach is very low, and normally pH the stomach try to maintain its lower pH. The why it is important for the stomach to maintain low pH? There are two reasons for the stomach to maintain low pH. First reasons that the low pH play role in the body natural defense systems. Due to the presence of due to the low pH and the presence of hydrochloric acids, it help to kill the microorganisms that is present in food. Mean it help to kill bacteria, other microorganisms that presents in food. The second important reasons is that it help to activate the digestive system present in the stomachs. As you know that our stomach contains enzyme pepsin, and pepsin help in the breakdown of proteins. It help to digest the protein in stomach. It break down the protein into amino acids. So for the pepsin activities, for the optimum catalytic activity of the pepsins require low pH. Pepsins pepsins work properly in mostly in 2 pH. If the pH of the stomach is 2, so pepsin activate and help to digest the protein. Clear? So that's why stomach maintain its low pH. And how they maintain its low pH? It's maintain low pH by hydrochloric acids. They release hydrochloric acid in the stomach, so it lower the pH of the stomach. Example 10.2. Calculate the pH and pOH of 0.0 molar solution of nitric acids. As we discuss it in previous lectures, that how you will calculate the pH and pOH of solution. We determine the pH, we already calculate the pH and pOH of the water in previous video. In this examples, calculate the pH and pOH of nitric HNO3. We have given data. Molar concentration of hydrogen is 0.01 molar. Are you divided 0.0 you 0.1 divided by thousands, so you will get 10 power minus 3. Clear? So the molar concentration of hydrogen is 0.01 molar or 10 power minus 3. Now find the pH and pOH of nitric acids. Solutions. First we will write the balance reactions, ionization reactions for the nitric acids. HNO3 ionize in hydrogen plus and NO3 minus in aqueous mediums. When we dissolve nitric acids in waters, it ionizes into hydrogen positive and NO3 minus. As we know that pH is equal to we define pH as minus logarithm of molar concentration of hydrogen ions. So as you know, the molar concentration of hydrogen ion is 10 power minus 3. So put the value in formula. We will get pH is equal to minus log 10 power minus 3. Take the log of 10 power minus 3. So you will get minus 3 log 10. As you know that the log 10 is equal to 1. Due to the mathematics rules, log 10 is equal to 1. Now the pH of the nitric acid is equal to plus minus minus. So you will get the pH of the nitric acid is 3. Now we will calculate the pH and pOH of the nitric acids. As we know that how you will find the pH pOH of the nitric acids. So we know the second formula, pH plus pOH is equal to 14 at 25 degree. pH and plus pOH is equal to 14. So we know the value of pH. Rearrange the formula. If you rearrange the formula, so pOH is equal to 14 minus pH. Put the value of pH in formula. pOH is equal to 14 minus 3. So 14 minus 3 is equal to 11. So pH of the nitric acid is 3 and pOH of the nitric acid is 11. If we add these two values, we will get the 14. So this relationship is true at 25 degree. Now, what is the type of solutions? On the base of the concentration of hydrogen and hydroxyls, there are three type of solutions: neutral solution, acidic solution, and basic solutions. Depend upon the concentration of hydrogen and hydroxyl ions. What is neutral solutions? So when the concentration of hydrogen and hydroxyl ion is equal to in a solution, so it means your solution is neutral. For example, pure water. Pure water has equal concentration of hydrogen and hydroxyl ions. That's why the pH of the water is 7. Clear? What is acidic solution? When the concentration of hydrogen ion plus is greater than the concentration of hydroxyl ion. For example, in vinegar. For example, vinegar, lemon juice, orange juice. These solutions contain greater concentration of hydrogen ion than hydroxyl ions. So we call it acidic solution. What is basic solutions? Solution in which the concentration of hydroxyl ion OH minus is greater than hydrogen ion. So it's mean your solution is basic solution. For example, soap solution. Soap solution contains greater concentration of hydroxyl ion than hydrogen ions. Detergent, toothpaste, baking soda solution. So aqueous solution of baking soda. So they contains greater concentration of hydroxyl ion than hydrogen ions, and we call it a basic solution. Look at this diagram. Acidic solutions, beaker contain greater number of hydrogen ion than hydroxyl ion. In neutral solutions, equal number of hydroxyl and hydrogen ions. As you know, as you see that there are 5 hydroxyl ions, so there are 5 hydrogen ions. Basic solutions, they contains greater number of greater concentration or greater number of hydroxyl ion. So with the due to the presence of hydroxyl and hydrogen ions, there are 3 type solutions: neutral, acidic, and basic. I hope you understand these 3 type solutions and also understand that how we will calculate the pH and pOH of different acid and basic solutions. In next video, inshallah, we will discuss neutralization reaction and salt.